Hi. In this video, I want to look at an algorithm that lets you do the kinds of things like find the closest thing in the room, or find, I'm doing all sorts of like Vogue poses, find the highest thing in the room. I don't know why I need to do that for the highest thing, but whatever. And this is a similar type of algorithm if you've ever looked at like a color tracking algorithm, find the brightest thing or find the most red thing in the room. I like to refer to this as like the world record algorithm, which means like I've got to look at every single pixel and keep track of which pixel is the record holder and hold on to that record holder, the closest thing, the highest thing, the most red thing, and when I get to the end, have that XY coordinate that I can use for something else. So a lot of things that you might do with the raw depth data of the Kinect could involve this, like if you know the person is always standing like this in a fencing pose, where is their hand? Because their hand is always the closest thing. Or if you want to determine if a person is moving up and down, how do you find the top of their head? What's the highest thing within a given threshold? So let me go over to the whiteboard for a second to just talk in generally speaking about how this kind of algorithm works. And then we'll go and implement it in a couple different scenarios. Okay, so as with just about everything that involves images and pixels or depth points, you've got this grid, right? And the grid has a bunch of x's and a bunch of y's, and there's always this loop. All the examples have this. For every x, for every I, look at every pixel. Now I've got some glare here, so hopefully you're going to be able to see what I'm writing, but I was going to say shout at me. Just shout at your computer screen or wherever you're watching this, and I will hopefully hear you someday. If you can't read what I'm about to write. But so the way that this works is you need to find the record holder. So let's say we wanted to find the closest thing. So remember, the depth values are between 0 and 4,500. So we could start by saying the initial record, right, the world record for the closest thing would be 4,500 because that's the furthest back. So any pixel that beats 4,500 is by definition the new record holder. So we have to say something like, if I have the current depth in a variable, I need to say if that depth is less than the record, then the record is now that depth. So this is the core algorithm for every pixel. Is the first one beating the record? It is. That's the record holder. Is the next one beating that record? No. Is the next one beating that record? No. Is the next one beating that record? Yes. Okay, that's the record holder. And while we're doing this, we could also keep track of, the record X and the record Y. So if every time we get that new record, we store that X and Y. So that by the time we get to the end of this loop, in those variables are the X and Y that win this record. Okay, so to demonstrate this example now, what I have is I've adjusted this example a little bit, and what it's doing now is it's showing you both the depth image as well as coloring particular pixels of that depth image, this pink color that are within this threshold. So now I need to figure out what pixel in that threshold is perhaps a record holder of some sort of record. So we'll look at the closest thing and also the highest thing. And I'm pretty sure the closest thing is going to not work that well, but the highest thing I'm hoping is going to work pretty well. So let's do the thing that's not going to work as well first. And let's just look at a little bit of what's changed in the code just to show you. So first of all, I'm looking at the depth image as well. And then what I'm doing is if this depth value is in the threshold, I'm setting that particular color to this pink value. Or purple value, I don't know what color it is, can't tell. If it's not, then I'm just pulling the color value from the depth image itself, then updating the pixels and drawing the depth image. So that is why you are seeing this particular result. It's essentially what I had earlier in the previous examples with just also adding in those depth pixels instead of black. So now we need to figure out this way of getting a record holder. So the first thing we need to do is say, at the beginning, what's the record distance? I'm looking for the thing that's closest. So the thing that's closest, the record to start would be something really, really high. So the record would be 4,500. That's as far as something is possible to be from the Kinect. Then I need the record X, which will be at 0, and the record Y, which will be at 0. So I want to test every pixel X and Y if it beats the record. If it does beat the record, set our X to that new X and set our Y to that new Y, and then draw a circle at that record value at the end. So right here, I'm going to check only inside the threshold. In a different scenario where I had the Kinect in like an open space, and a sort of flat wall, and people just came into the middle, I wouldn't really need to do this thresholding thing because but there's so much stuff in this room. There's a desk, there's a computer, there's a wall, that it's not so, that I think using the threshold here helps it be a little bit more accurate. So I can say if that distance is less than the record, then the new record is that particular distance, right? For every single pixel, does that pixel beat the record? If it does, I've got a new record. And if it beats the record, then I need to save that particular x and y in Rx and Ry. So all we need to do this kind of record algorithm is a starting record, a starting Rx and Ry, and then every time we beat that record, save those two values. And then at the end, I can draw a circle at Rx and Ry. And I'll just make that circle white, so it we pick it up, and we can see now. Okay, now first of all, you can see that circle is just jumping around. That's because first of all, there's very little. There's like stray pixels that are making it in the threshold. So now you can see that it's kind of working now. You can see that white circle is following my hand. Now notice this is much less accurate than what I did before with this sort of average section of pixels. Mostly because anytime you're looking for a single pixel, it's not such a great thing. I kind of want to find a group of pixels that are like beating that record. But that aside, you can see the basic idea is working. But it's really like if I come and stand in here, like there's a lot of me that's in the threshold, but my head, as I'm bending over, is closer. So you can see if I move my hands out, they're a little bit closer. If my shoulder comes in, my shoulder is the closest thing. So you can see it's jumping around a lot, but it's always finding the particular pixel that is closest. It's just sort of demonstrating the idea, but let's change it now. Let's have it find, I'm going to stand here to sort of, let's have it find the pixel that's highest. And I'm a little worried we're going to have a little bit of an issue because you can see it's something jumping to the top. But let's see, because there might be some stray pixels that it's picking up that are but let's see if we can get it to work. So what is the record now? So the pixel that is highest could be 0. The record would start at the height of the screen. So I'm going to comment this out. I'm going to leave both of these in this example. I'll try to post this code somewhere. You could download it and put a link in the video description. So the record would now be the height of the window, or I could really say, it really makes sense here to say depth height. So that's the starting record. And now if inside this threshold, distance, that's not the depth. What I want to know is if y beats that record. So if this particular y pixel is just, I'm looking for any pixel inside that threshold that's very high, then I've beaten that record. So the record equals that y value, save this, save the x and the y, and then draw it. So the same exact idea, I'm just changing what the test is. Like the height is the y value if it's less than that record. So now we'll run this, and we can see it's picking up a lot of noise, but if I come in and bend down, so there's too many pixels up top. You can see that it's flickering. There's too many pixels up top that are pulling up some sort of value. So I'm going to try to do like a little bit of a hack here again. We're going to say, and I'm going to say, let's skip the first like 50 pixels. I'm only going to look, and let's see if this helps. There we go. So now you can see I'm getting the top of my head pretty accurately. If I move my hand up here, I'm getting the top of my hand. So if I had a particular project that wanted to have something move based on whether I'm moving up and down, this is good, I'm going to do some extra squats here. You can see that this works. So, I had to sort of like calibrate and do some goofy things, but you can see this is a very simple way of just finding the top. So like people always get obsessed with like finger tracking. Like, let me find the finger, but you can see how accurate this is. I'm just getting like the tip of my finger now. There's no finger tracking here. It's just like if I go like this, it's getting the top of my elbow. But if you tell people to stand like this and wave their finger, you can see how like kind of super accurate that tracking is just from looking. This is like the simplest thing ever. I'm just looking for the top pixel inside this threshold. So hopefully this shows you a few types of things you can do. We've seen a range of things of just sort of visualizing the 3D data, from like looking for thresholding it in between, for tracking the height of something, the average location. This is where I'm finishing this video set today. But there will be some more ones. I guess, who knows when you're watching this, the more ones might already exist, the more ones, and you'll see them in the next video. Okay, so thanks for watching. And I will talk to you soon. Okay, goodbye.